You know how we're constantly using more and more apps and digital services? Like, it seems like every single day.
Yeah.
Well, it's like all this stuff is driven by code, right? By these systems working behind the scenes,
Right.
automated systems.
Yeah.
But like, as these digital assistants, you know,
Right.
all these things become more sophisticated and there's more of them.
More numerous.
Yeah, more numerous. It
Mm.
kind of makes you wonder, like, how do they actually talk to each other?
Yeah. It's like having a room full of people
Right.
all speaking different languages.
Yeah.
How do they coordinate?
It's a recipe for disaster.
Yeah. And that's becoming a real hurdle for progress.
Huge hurdle.
Yeah. A huge hurdle.
So that's actually what we're going to dive into today,
Mhm.
something called the Agent Communication Protocol.
ACP.
ACP, exactly.
Nice and short.
Yeah.
Easy to remember.
So you can think of this as kind of like a universal translator
Right.
for all of these autonomous agents.
Mhm.
It's a new framework that's aiming to standardize the way that they interact.
Yeah. How they talk to each other, basically.
Exactly. So ACP is our main focus today.
Our deep dive.
Our deep dive.
Yeah.
We've been going through a lot of the sources that are out there on this, and what we want to do is just unpack for you what this is, why it's suddenly,
Gaining traction now.
yeah, why is it gaining traction now, and, what are some of the strengths of this new protocol, and then,
What are the bumps in the road we might hit?
yeah, exactly,
Oh.
the potential downsides,
Yeah.
and we want to do all this without,
You don't need a PhD to understand this.
yeah, you don't need a PhD in computer science to understand this. We're going to make this really accessible.
Absolutely.
So really, ACP is tackling, I think, a really fundamental problem
It is.
in this whole world of autonomous systems.
Right.
We're seeing so many different communication methods
Yeah.
being used by all these different agent platforms.
Yeah. There's no standard right now.
Yeah.
This isn't doing their own thing.
Yeah, and it's leading to these like digital silos
Mhm.
where you can't get these different agents to talk to each other.
Especially if they're built by different teams or companies.
Uh-huh.
It's like
Yeah.
you're trying to build a house,
Uh-huh.
but the electrician only speaks French and the
Ugh.
plumber only speaks German.
Right. It's not going to work.
How do you coordinate that it's a mess?
So if I'm getting this right, the main goal of ACP is to be that.
That common language,
The common language, that shared set of rules.
the Rosetta Stone.
Yeah, the Rosetta Stone, so that all these different autonomous agents can understand each other and work together
Exactly. And work together seamlessly
seamlessly
without any hiccups.
without any hiccups.
I like it.
So we're talking about, being able to solve complex tasks
Mhm.
that might require lots of different autonomous systems to cooperate.
Yeah, to work together.
Yeah.
So what's interesting, too, is that this is built for agents that deal with natural language.
Oh, this is a key differentiator.
Yeah.
This is not just for like,
Machine-to-machine communication. This is for agents that are designed to interact with humans.
and humans are messy
Humans are messy.
with their language.
We use slang. We're ambiguous.
Yeah.
We sometimes don't even know what we want.
Right. And a lot of these agents also use these AI models
Yes.
that are hosted externally.
On the cloud somewhere. Yeah.
Yeah. So this has to deal with that too.
ACP has to handle all of that.
So it's purpose built for these.
Intelligent agents.
Yeah. For these intelligent agents.
That's what makes it so interesting.
So let's talk about the advantages then.
Okay. The aha moments.
The aha moments. Yeah. What are the real game changers here?
Well, the first one that really jumps out is interoperability.
Okay.
So think about all the smart devices in your home.
Yeah.
You've got your smart lights,
My smart lights.
your smart thermostat,
Smart thermostat. Yeah.
your smart security system.
Yep.
Wouldn't it be amazing if all of those could seamlessly talk to each other,
That would be.
regardless of who made them? So your security system could tell your energy management system,
Mm-hmm.
hey, nobody's home. Let's turn down the heat.
Right. Save some energy.
Save some energy and money.
Yeah.
That's the kind of world that ACP is trying to build.
Yeah. So it's not just about agents talking to each other. It's about
It's about breaking down those silos.
breaking down those silos.
Yeah.
So no more being locked into one ecosystem.
Exactly. You're free.
That's a pain.
It is a pain.
So what else is there?
So another big benefit is simplified development.
Okay.
So right now, developers spend a lot of time
A lot of time.
figuring out how to get all the different parts of an agent system
Uh-huh.
to communicate with each other.
Uh-huh.
It's a lot of overhead.
Yeah.
ACP provides a standard way to do that,
Right.
a blueprint, if you will.
Yeah.
So developers can spend less time on the plumbing
Right.
and more time on building the actual intelligence of the agent.
I like that analogy.
Yeah, it's all about freeing them up to innovate.
So it's less time on the boring stuff. More time on the cool stuff.
The cool stuff, the fun stuff, yeah.
The fun stuff. Okay.
And this leads to the next benefit, which is reuse and efficiency.
Okay.
So because ACP defines these standard patterns for communication,
Uh-huh.
developers can reuse solutions that have already been proven to work.
So they don't have to reinvent the wheel every time.
Exactly. It's like having a library of communication modules
Okay.
that you can just plug and play.
So it's like a toolkit.
Yeah, like a toolkit for building agent communication.
I like that.
Yeah, it's very efficient.
Okay, cool. So we've got interoperability, simplified development, reuse, and efficiency, and we're not done yet.
Not even close.
Okay, hit me.
So another big one is natural language flexibility.
Okay, this is important.
This is huge because,
Yeah.
like we said before, humans are messy with language.
So who are?
ACP is designed to handle that messiness.
Okay.
So it can understand our intent even if we don't say things perfectly.
So like even if we're being
Vague.
vague or using slang or...
Contradicting ourselves.
yeah, contradicting ourselves,
It
yeah.
can figure it out.
Okay, so that's really important for making these agents feel more human-like.
Exactly. We want them to feel like helpful assistants,
Right,
not like robots.
not like robots.
Yeah.
Okay, I'm with you.
Okay, and then the last big benefit I want to highlight is model dependency management.
Okay.
So a lot of these really smart agents,
Mm-hmm.
they rely on AI models
Right,
that are hosted somewhere else
on the cloud.
on the cloud, yeah.
Right.
And these models can be huge.
Oh, yeah.
They can take a lot of computing power.
Uh-huh.
ACP makes it easy for agents to connect to these models
Okay.
and manage them.
So it's kind of streamlining that whole process.
Exactly. It's making it more efficient.
Okay, cool. So those are like 5 big aha moments for ACP.
5 big reasons why people are excited about it.
Yeah, I'm getting excited.
Yeah.
So let's get a little bit more technical then,
Okay.
without getting too lost in the weeds.
Right. We don't want to lose anybody.
Yeah. So how is ACP actually built?
Okay, so at its core,
Hmm?
ACP uses something called JSON RPC.
JSON RPC.
That's a mouthful,
It is a mouthful.
but it's actually pretty simple.
Okay.
So JSON, you could think of that as a way to structure data.
Uh-huh.
Like if you were writing down information on a piece of paper,
Okay.
JSON is a way to organize that information.
So it's a standardized way of writing things down?
Exactly. It's a standard format.
Okay.
And then RPC, that stands for Remote Procedure Call.
Okay.
And that's the mechanism that allows one program
Okay.
to ask another program to do something,
Okay.
even if that other program is on a different computer.
Oh, interesting.
Yeah. So you can think of it like this.
Okay.
You write a message on a piece of paper,
Uh-huh.
you put it in an envelope,
Okay.
you address it to the other program,
Okay.
and you send it off.
Got it.
And the other program opens the envelope, reads the message,
And does what it says.
and does what it says.
Okay.
So JSON RPC basically combines these two things.
The message and the sending.
Yeah, the message format and the sending mechanism.
Okay.
And it provides a really lightweight and flexible way for agents to communicate.
So this is how those messages actually get from one agent to another.
This is the how.
Okay.
Yeah.
Cool. So then how do those messages actually travel?
So that's where transport mechanisms come in.
Transport mechanisms.
Yeah, and this is another really cool thing about ACP.
Okay.
It's transport agnostic.
Meaning?
It doesn't care how the messages are sent.
Okay.
It can work over different technologies,
Okay.
like HTTP.
Okay. Everyone knows HTTP. That's like the web.
That's the web, yeah.
Yeah.
Or it can work over WebSockets,
WebSockets.
which are more persistent connections.
Okay.
So it's like choosing between sending a letter
Uh-huh.
or making a phone call.
I get it.
Yeah. Depends on what you need.
Right.
So ACP is very adaptable.
It can work over different channels.
Exactly. Different channels.
Okay.
Yeah.
And then to handle all the different ways that these agents might want to talk to each other, ACP supports both stateless and stateful communication.
This is an important distinction.
Yeah.
So stateless communication,
Uh-huh.
that's like a one-off interaction.
Okay.
You ask a question, you get an answer.
Like a Google search.
Like Google search, yeah. There's no memory of past interactions.
Right.
Each request is independent.
So it's like a fresh start every time.
A fresh start every time, yeah.
Okay.
And it's often associated with the REST architectural style.
Rest.
It's REST.
Yeah. Right. Okay.
And it's great for simple interactions
Mm-hmm.
where you don't need to remember anything,
Like a weather app.
like a weather app.
Yeah.
Yeah. Just give me the current temperature.
Exactly.
I don't need to tell you what the temperature was yesterday.
Yeah.
You don't care.
And then there's stateful.
Stateful communication.
This is where you need to remember stuff.
Exactly. This is like a conversation
Okay.
where you're building on what was said before.
Okay.
So you need to keep track of the context.
Right.
And this is often implemented using technologies like WebSockets
Okay.
or server sent events, which is also known as SSE.
Okay.
So those are more persistent connections.
So it's like an ongoing chat.
Yeah, like an ongoing chat.
Okay.
And this is good for more complex interactions
Mm-hmm.
where you need to remember what was said before.
Like a chatbot.
Like a chatbot, yeah.
That needs to remember your order history.
Exactly.
Going.
Yeah, or like a collaborative document editing tool
Oh, right.
where multiple people are working on the same document at the same time.
Yeah. You need to keep track of all those changes.
You need to know who made what change and when.
Yeah, that makes sense.
Yeah, so stateful communication is all about maintaining that context.
Oh, okay. So how does this actually look in practice with ACP?
Okay, so let's look at some examples.
Okay, cool.
So for stateless agents,
Uh-huh.
there's often a single method that's used to make things happen.
Okay.
It might be called something like agents run.
Agents run.
Yeah. And this one method, it would handle everything.
Right.
Like creating the agent if it doesn't already exist,
Okay.
running the agent with some input that you give it,
All right.
and then maybe even cleaning up afterwards.
Okay.
So it's like a one-stop shop,
One and done.
one and done. Yeah.
And this aligns really well with REST.
Oh, perfect.
Because
Tom.
REST is all about those self-contained requests.
Exactly. Each request has all the information it needs.
Uh-huh.
It doesn't need to remember anything from previous requests.
And it would look something like this.
Yeah. Here's an example of a JSON RPC message for this.
Okay. JSON, hey G, MSG 001. JSON RPC 2.0 method. Agents run, params, name, agent name, input, hello world, input. So that's for stateless.
That's stateless.
What about stateful?
So for stateful agents,
Uh-huh.
ACP typically uses separate methods
Okay.
to manage the different stages of an interaction.
Okay.
So you might have an agents create method
Okay. To start things off.
to start things off. Yeah.
Uh-huh.
And that would create an instance of the agent
Uh-huh.
and establish a session.
Okay.
And then you would use an agents run method
To actually run it.
to actually run it. Yeah. But this time,
Mm-hmm.
it would be sending input to that specific instance of the agent
Okay.
that you created earlier.
So it's building on that existing session.
Exactly. It's like a conversation.
Yeah.
And then finally, you would use an agents destroy method
Okay.
to end the session
Right.
and clean up.
So it's like a create, run, destroy life cycle.
Exactly. A life cycle.
Yeah.
And here's some examples of those JSON RPC messages.
Okay. JSON. Create. MSG-001. JSON RPC 2.0 method. Agents create. Params, template name, agent name, config, params, accrued, MSG002, JSON RPC 2.0 method, agents run, params name, agent name 001, input, hello world, input, destroy, MSG003, JSON RPC 2.0 method, agents destroy, params, agent name -001, params. So you can really see the state being managed there.
You can, yeah.
Okay, so this is all really interesting and it sounds very promising.
Yeah.
But I'm sure there are some challenges
Oh, there are always challenges.
when you're
yeah.
developing something this new.
Especially with something this complex.
Yeah.
So one of the big challenges is just deciding which transport mechanism to use.
Right, REST versus WebSockets.
Yeah, because that decision
Uh-huh.
has a big impact on how you design and implement ACP.
Okay, so you really have to think about which one is right for your particular use case.
Exactly. And you have to think about things like, what if some agents don't support all the features
Right.
of a particular transport mechanism?
Right, so you need to make sure it can still work, even if...
Even if there are some limitations.
Yeah.
And you also have to think about things like
Uh-huh.
standardized headers
Okay.
or metadata
Okay.
that you might want to include in the messages.
So make sure that everyone can understand each other.
Exactly, to improve interoperability.
Right.
Yeah.
So it's a lot about finding the right balance
It is a balancing act.
between flexibility and consistency.
Right. You want it to be flexible enough
Uh-huh.
to work in different situations.
Yeah.
But you also want it to be consistent enough
That everyone can use it.
that everyone can use it. Yeah.
Okay. And then another challenge I'm thinking about is state management.
Oh, yeah. That's a big one.
Because, like we said, ACP is designed to minimize the amount of state that it has to keep track of.
At the protocol level.
At the protocol level, yeah.
Yeah.
But these individual agents,
Right.
they need to be able to manage their own state.
They need to remember things.
They need to remember things.
Yeah.
So how do you do that?
Right. So how do you do that in a way
Mm-hmm.
that's efficient
Yeah.
and doesn't bog down the system?
Right. Because if every agent is keeping track of all this information,
It could get really messy really
it
quickly.
could get really messy and really slow.
Yeah, exactly.
Yeah.
So there's a lot of research going on in that area.
Okay, so this is an area of active development.
Very active development.
Yeah.
Yeah.
And I guess that kind of leads into the challenge of scalability and performance.
Right, because as we build these more and more complex agent systems with lots of agents and lots of interactions happening,
Right.
we need to make sure that ACP can handle that load.
Yeah, we don't want the whole thing to grind to a halt.
We don't want it to collapse under its own weight.
Yeah.
So performance is a huge consideration.
So are there people working on this?
Oh yeah, there are a lot of smart people working on this.
Okay, that's good to hear.
Yeah, it's a very active area of research.
Yeah, so it's not like a finished product.
No, it's very much a work in progress.
But it's exciting
It's very exciting.
to see where it's going.
Yeah, it has a lot of potential.
Yeah. So who is driving this development?
So one of the most exciting things about ACP is that it's being developed by the community.
So it's not like one company.
It's not like one company dictating everything.
Yeah, that's okay.
It's a bunch of developers and researchers and organizations who are all working together.
To make this thing happen.
Yeah, because they all see the need for a standard,
Yeah.
and they all want to make sure that it meets the needs of the real world.
So that's a good sign.
It's a very good sign.
Yeah, that it's not just some ivory tower.
Exactly. It's grounded in the real world.
Yeah. Okay, so what are some of the things that they're working on?
So one of the big things is developing flexible standards,
Okay.
because the world of AI and agent technology
Yeah, it's moving fast.
is moving so fast.
Yeah.
So they don't want to create a standard that's too rigid.
Right, because it could become obsolete very quickly.
Exactly.
Okay.
So they're trying to build in some flexibility.
Yeah, future-proofing it.
Future-proofing it, yeah.
I like it.
And they're also really focused on interoperability and reuse,
Okay.
which makes sense.
Yeah, because that's the whole point.
That's the whole point of ACP,
Right?
to make it easy for different systems to talk to each other.
And to reuse those existing solutions.
Yeah, to avoid reinventing the wheel.
Okay, good.
Yeah. And then, because ACP is specifically for intelligent agents,
Yeah.
there's a lot of discussion about how to handle natural language
Okay.
and how to manage those external AI models.
Right, because those are two of the big things that make these agents special
Exactly.
and challenging.
And challenging, yeah.
Okay, cool.
And then the last thing I'll mention
Mm-hmm.
is that they're working on creating really good documentation.
Oh, that's important.
That's so important.
Because even if you have a great standard,
If nobody knows how to use it,
and nobody knows how to use it,
it's useless.
it's useless.
Yeah,
Yeah. So they're putting a lot of effort into that.
they are.
Okay, good.
Yeah.
So let's go back to this stateless versus stateful thing for a second.
Okay.
Because I think it's really important for understanding ACP.
It is a fundamental concept.
Yeah. So can we just recap the main differences?
Sure.
And maybe tie it back to those JSON examples that we were looking at?
Absolutely.
So stateless agents.
Stateless agents are all about simplicity.
Okay.
They're easy to build,
Uh-huh.
and they're easy to scale,
Meaning,
meaning you can handle a lot of them at the same time
right.
without the system falling apart.
Yeah.
But the trade-off
Mm-hmm.
is that they're not very good at handling complex interactions.
Right. They don't remember anything.
They don't remember anything.
From previous interactions.
Yes, it's like a one-night stand.
Okay.
You meet someone, you have a good time,
Huh.
and then you never see them again.
You move on.
You move on. Yeah.
Okay.
So if we look at that JSON example for stateless agents,
Mm-hmm.
with that single agents run method,
Yeah.
that really highlights the point.
Yeah.
You send in your request, you get your response.
Done. No
Right.
strings attached.
No strings attached.
Okay.
But then you have stateful agents,
Right.
which are the opposite.
Okay.
They're more complex to build,
Uh-huh.
and they're harder to scale,
Right.
but they can handle those complex interactions.
Right, because they can remember things.
They can remember things. So
yeah.
it's like a long-term relationship.
Okay.
You get to know the other person,
Yeah.
you build a history together,
Uh-huh.
and that makes the interactions richer.
And you have to put in more work
You do have to put in more work
to maintain that relationship.
to maintain that relationship.
Yeah.
And if we look at those JSON examples for stateful agents,
Uh-huh.
with those separate create, run, and destroy methods,
Yeah.
that really shows how state is being managed.
Yeah, you have to explicitly create the session.
Right, you have to set it up.
Yeah.
And then you can have multiple interactions
Within that session.
within that session.
And then you have to explicitly end the session.
Exactly, you have to break up with them.
Yeah.
Yeah.
So it's more work,
It is more work.
but it's also more powerful.
It is more powerful.
Yeah.
Yeah,
Okay, so I think we've got a good handle on that distinction now.
I think so too.
So let's talk about transport mechanisms again.
Okay.
We talked about REST and WebSockets,
Mhm.
but can we dive a little deeper into why you might choose one over the other.
Sure.
So REST is really good for those simple, scalable interactions.
Right.
Because
each request is self-contained.
yeah.
It doesn't need any information from previous requests.
Right. So you can just fire off those requests
You can just fire them off.
to different servers.
Yeah.
And doesn't matter what order they come back in.
It doesn't matter at all.
Okay, so that's why it's so scalable. Okay, and then WebSockets.
WebSockets are for when you need that real-time two-way communication.
Okay, so this is like
This is like a chat app
a chat app,
or a video call
a video call, yeah.
where you need that constant stream of data
Back and forth.
back and forth. Yeah.
Okay.
So WebSockets provide this persistent connection
Yeah.
between the two parties,
Okay.
so you don't have to keep opening and closing connections,
Yeah, which is more efficient.
which is much more efficient.
Okay.
Yeah.
And there's a whole handshake process involved?
There is. Yeah. It's like knocking on the door
Yeah.
before you can come in.
Got it.
Yeah.
And then what about SSE?
So SSE is kind of like a one-way street.
Okay.
It's for when the server needs to send updates to the client,
Uh-huh.
but the client doesn't need to send anything back.
Okay.
So it's like a news feed
Okay.
where you're constantly getting new articles,
Right.
but you don't need to send anything back to the server.
Unless you're leaving a comment or something.
Right, unless you're interacting with it in some way.
Yeah.
So it's a simpler, more lightweight alternative to WebSockets.
Okay, so it's all about choosing the right tool for the job.
Exactly.
Yeah.
And ACP gives you that flexibility.
I like it.
Yeah.
So we've talked about a lot of the technical details, but I think it's important to talk about security as well.
Oh, absolutely.
Because when you have all these agents
Talking to each other.
yeah, exchanging information,
Yeah.
security is paramount.
It's non-negotiable.
Yeah.
So what are some of the things that ACP does to make sure that these communications are secure?
Okay, so one of the big things is encryption.
Okay.
So using protocols like IPsec and DTLS.
IPsec and DTLS.
Yeah, those are just names of protocols.
Okay.
But basically what they do
Ah.
is they scramble the data
Okay.
so that only the intended recipient can read it.
So if someone intercepts the message,
I can't understand it.
they just see gibberish.
Exactly.
Okay. So that's like the first layer of defense?
Yeah, the foundation.
Okay. And then another important aspect is certificate management.
Okay.
So digital certificates,
Mm-hmm.
they're like digital IDs.
Yeah.
They allow agents to prove who they are
Okay.
and to make sure that they're trustworthy.
Okay, so it's like a way to verify their identity?
Exactly.
Okay.